Hello friends, welcome to today's knowledge-filled video. You all must have seen ice many times in your life, whether it's the ice cubes coming out of the refrigerator, the pieces of ice floating in a cold drink, or the thick sheets of snow covering the mountains during winter. But have you ever thought deeply about how ice actually forms? And once it's right in front of us, why does it slowly melt away? That's exactly the fascinating journey we're going to explore today. From the making of ice to the reasons behind its melting, explained step by step with real science. Let's begin with the simplest yet most magical substance we know: water. Water is the basis of life on Earth, and when its temperature changes, it appears in different states. Normally at room temperature, water exists as a liquid, but as its temperature drops lower and lower, it gradually changes into a solid state. When the temperature of water falls to 0 degrees or below, the molecules of water slow down in their movement. At normal temperatures, these molecules move around freely and quickly, but when cooled, their motion slows dramatically. As they approach freezing point, they start locking together through special bonds called hydrogen bonds, forming a solid crystal-like structure. This very structure is what we call ice. This process of ice formation may look simple, but scientifically it is absolutely fascinating. In fact, when water freezes into ice, its volume increases. This is the reason why ice floats on water. If this property didn't exist, the ice formed in lakes and rivers would sink to the bottom, creating a dangerous situation for life. Now let's come to the real question. Why does this solid, hard-looking ice melt? The answer lies in heat energy. Whenever ice comes in contact with its surrounding environment, the environment usually has a temperature higher than 0 degrees C, whether it's air, sunlight, the surface it's placed on, or even the warmth of our hands. All of these provide heat energy to the ice. As soon as this heat energy reaches the molecules of ice, they begin to vibrate more and more. Their motion becomes faster. Slowly, the hydrogen bonds that were holding the molecules in place begin to break apart, and the molecules regain their freedom of movement. This is the exact moment when solid ice turns back into liquid water. This process is known as melting or fusion. But here's the interesting part. Melting isn't just about raising the temperature. Ice requires a specific amount of energy before it can fully turn into water. This special amount of energy is called the latent heat of fusion. For water, this value is 334 joules per gram. In simple words, if you have 1 gram of ice, it will take 334 joules of energy to completely convert it into water, even if its temperature is already at 0 degrees C. Now imagine holding a piece of ice in your hand. Your hand slowly transfers this energy to the ice, and as a result, the ice begins to melt into water. That's why you feel the icy coldness and tingling sensation in your skin when you touch it. The speed at which ice melts depends on many factors. The first and most obvious one is temperature. The higher the surrounding temperature, the faster ice will melt. The second factor is pressure. If you apply very high pressure on ice, its structure becomes unstable and it melts faster. This is exactly why ice skating works. The sharp, thin blades of the skates put pressure on the ice, causing a thin layer underneath to melt and create a slippery surface. The third factor is impurities. If substances like salt are added to ice, its melting point lowers. This is why, in cold countries, salt is spread on icy roads to melt the snow and ice quickly. Another important factor is the surface on which the ice is placed. If the surface is warm, the ice will melt much faster. That's why ice kept in direct sunlight melts far quicker than ice kept in the shade. Let's understand this with a simple, everyday example. Suppose you pour yourself a cold drink and drop an ice cube into the glass. At first, the ice cube cools your drink. But in just a short while, you'll notice the ice cube getting smaller and smaller until it vanishes into water. This happens because the walls of the glass, the air in the room, and the drink itself are all warmer than the ice cube. All this heat constantly transfers to the ice, melting it away. When we look at this process more deeply, we realize that melting of ice is purely a physical change, not a chemical one. No matter how much the ice melts, the substance remains the same: water. Its chemical structure, H2O, doesn't change at all. The only difference is in its state. It changes from solid to liquid. This property of water is extremely important for life on Earth. Imagine if the melting point of water were different, or if ice didn't float on water. Our lakes, rivers, and even oceans could have frozen completely, making life impossible. Nature has beautifully balanced these properties to sustain life on this planet. So friends, next time you see ice, don't just think of it as a cooling element in your drink. Think of it as a living lesson of science, a tiny piece of matter that carries within it the mysteries of energy, molecular motion, and the laws of nature. I hope you enjoyed this complete story of how ice is formed and why it melts. The next time you encounter an ice cube or see snow on the mountains, you'll understand the fascinating science hidden behind it. If you found this video informative and interesting, make sure to hit the like button, share it with your friends and family so they too can learn the scientific secrets of ice. And of course, don't forget to subscribe to our channel so you can keep receiving more such videos full of real knowledge and fascinating science. Thank you.